Assalamualaikum warahmatullahi wabarakatuh and good morning class.
Assalamualaikum. Good morning.
Assalam, sir.
Okay, so how's the midterm test? Easy, right? Right, so today we are going to discuss on a new topic. So this is a new topic, loop logic structure. And it is I can say that this is the most important knowledge that you must master. Not only for these subjects, but it will be used throughout your studies in UMP lah. Okay, all other subject, if it is involving any programming, okay, you will need to use these techniques, okay, loop logic structure. And it is not that hard. So this topic compared to decision, it is easier, okay. You just have to understand what are the elements to put in your design or in your program if there's a looping, okay. And the elements is it is the same for all the programs. If it is involving looping, it is the same, okay. You just have to know where to put it. That's all. It's got some sort of a template, okay, where you can apply in all of the program. Okay. If you refer to the notes, so this is the part that covered in the notes, but I'm not going to use the notes entirely, because if I follow the flow in the notes, I'm afraid that some of you will get lost. That's why for the looping, I prefer to go basic from scratch. Okay, so here it is. I'm going to use words. All right, so let's start. Okay, first we go for the reason. So the reason for looping. Why we need looping in our program? So previously, when we discussed on the sequential logic structure and the decision, actually, if you pay attention, you will get some problems, okay, arise from if we are applying sequential logic structure or decision logic structure alone, okay, without having a looping inside of it. Okay. So later on, we are going to see what's the problem. So the main reason, can you see my screen, class?
Yes, sir.
The main reasons why we apply looping is, first, when we want to do accounting in our program. And most of the time, we require accounting. Okay, it is sometimes you notice this one. Okay, sometimes it is happen. It is there in your program, but you couldn't notice it. But most of the program require counting. For whatever reason, but there will be a counting. Okay, so what is accounting? Counting is something like this. 1, 2, 3, 4, 5, and so on. So this is what we call as accounting. Okay. Or it can be 2, 4, 8, and so on. Counting. Okay. And then the second one is why we need to apply looping is because we want to accumulate something. Okay. For example, okay, we need a program to calculate sum of two numbers. So we use equation sum equal to 1, for example, this is for example, 1 plus 2. So the answer is 3, right? So this is in the first run of the program, and then the second run of the program, we want to do sum of 3 and 3. So the value is 6. Okay. So when we say accumulate, so we want to accumulate the first sum with the second sum. Okay, the first sum is 3, and so the second sum, the second run of the program, calculate sum, the value of is 6. And then when we run again the program, let's say this time we want to do summation of 1 plus 1. So accumulation is 3 plus 6 plus 2. So this is accumulation. Okay, when we run the program 3 times. So this is what we call as accumulation. These are the main reason. Okay, and then we apply this in many techniques. Okay, for example, there's an array, there's many other things. Okay, that is applying, counting, and accumulating. But this is the basics. Okay, the basic why we apply looping in our program. Okay. So this is the reason. And then there's the types. Okay, there are 3 types of looping. 8 types of looping. The first one is while. Or if you refer to the notes, while end. Okay, while end is the closing. And then we have do while. Or if you refer to the notes, it will state this one is repeat until. Okay, do while. And the last one is generally known as for loop. Okay, if you refer to the notes, you will refer as automatic loop. This one is repeat until. If I'm not mistaken, repeat until. Okay, so there are only 3 types. Okay, so how to apply this three types of looping? There's a template of it. So you just need to understand and apply this template in any of your programs, existing program, then it will become a loop program. All right. So let's go for the first types of looping, which is while. Okay, while loop. Okay, so before we go in details, let's say we have. Okay, let's go for one example. Example, I think we already look at this example during the sequential logic structure. Okay? For example, we have one simple program. Program to calculate average. Okay, the average of three different percentage. 4 lah banyak sikit. 4. Okay, enter H. Okay, I use a different symbol, but you may combine. I use this so that you may see it clearly. Okay, the difference. Okay, of course you cannot use the same variable kan. If it is a sequential logic structure, if you use the same variable name, if user enter H1 1, H2, H1 this one, user enter 2. This one user enter 3. This one user enter 4. So can we recall back H1 class? Cannot, right? So this value already been replaced by the latest value of H. So you cannot use the same variable name if it is a sequential logic structure. Okay, so you need to use different name so that it can hold 4 different values, right? And then we calculate the, let's say we go step by step. This one is a summation, eh? Sum H1 plus H2 plus H3 plus H4. And then how to calculate average? How to calculate average?
Sum over 4.
Okay, good. And finally, we print the value, eh? We print the value of, okay, let's say we print only average. And sum lah. Okay, sum and average, for example. Then N. Okay, you can straight away see the limitation of this design, eh? Which is, if let's say we have to calculate, okay, we have to calculate the average of 100 each. So what will happen to our program? Okay, this symbol over here representing at least minimum single line of codes, okay, in our program. So let's say if we want to enter hundreds each, so minimum we must have in our program at least for inputs is 100 lines, okay, which is not good lah. Okay, as we discussed before this, kan, if you have a longer design, meaning that longer program, meaning that your program required more time to complete, so it will become slow lah. So not good, eh? Okay, so that's a limitation. If you are applying a sequential logic structure to solve this simple problem, eh? So here comes the looping. Okay, to avoid a program to become repeating redundant instructions. Okay, redundant instruction lah. So this first instruction, second, so these are redundant. Eh? So in order to optimize the program, so we must use looping. So how to use looping? First, you need to identify in your program, okay, which part of the instruction is repeated. Over here clear, kan? Because I already draw the flow, kan? So we can clearly see the elements that is repeating, kan? So note down which part is repeated. Okay, for example, this one is repeated over here. What else is repeated, guys? Can you see which part is repeated? Is this considered as repeated, class? For the
Yes.
summation. Yes, can? Okay. Okay, so this is also repeated. Okay. Let's say if there's 100 each. So we repeat the process 100 times. Huh? So it's going to be longer summation, 100. So this also need to be reduced. Right? How about this one? Is it repeated?
No.
No. No or yes?
No.
Of course, no, kan? So repeating statements is clear. Okay, this is repeat. This is repeat. Clear, eh? How about this one? Is it repeated? Do we need to print sum and average 100 times if we do summation for 100 each? Do we need to print it 100 times? No. Clear, okay? So this is not a repeated statement. So identify which part of the process is repeated. Okay, and then you may start with the modification. Okay. Right. Okay, so to start using the looping, so you must understand that looping, when you want to apply looping, you have to apply the concept counter. Okay, counter concept. Counter is a variable. Okay, you may use a different name. Okay, you may use different names. Okay, counter, whatever lah. I couldn't think of any other names. But it is a counter. Okay, the use is this counter is used to control your looping. Okay, and counter will appear in 3 different places in your design. Okay, first counter. Okay, first counter will appear during the initialization. Okay. Then counter will appear in the condition. Decision lah. Decision. Okay. And then counter will appear for the updation lah. For the update. Okay, so the first thing is initialization. Okay, initialization, if you remember, I think I mentioned this quite a few times, kan? Initialization. Initialization is, this is equation, kan? This is equation. So this symbol, if you remember, so this symbol can only be used if either you use it for the equation or use it for initialization. Example of initialization is number equal to 10, for example. Okay? Initialization, we want to put a value to a certain variable, we use this symbol. Okay, the assignment symbol. Okay, either use it for equation or use it for initialization. So same goes for this initialization. So what you need to initialize? You need to initialize the initial value of the counter. So let's say we use counter as the variable. Okay, so we need to put the first value. Okay, as I said, counter is used to control your looping. It control where your where your loop start, and it control where your loop should end. Okay, so initialization is used to trigger the start. Okay, starting point of your looping. So where do you want to start your looping? Okay, let's say the common value for initialization is either you use 0 or 1. Okay, based on your design. Okay, it is actually up to you. You may start with 10. It's okay, no problem. Okay, but the most common one is we start with either 0 or 1. So let's say we start with 0. Okay, later on we'll see what if we start with other value. Okay, so we start with the initialization. Next is, okay, next is, okay, for the while. Next is straight away, okay, from this design, straight away we see that we execute the repeated process. Straight away, kan? There's no other process. Kan? For example, over here, there's a calculation, which is not which is not looping. So we put the equation over here, which is not looping. Example, just to show you the example. Let's say over here, before we enter age 4 times, there's an equation. Example. not logic, but example. There's A plus Z over here. Okay, before enter H. Okay, so supposedly over here, F, example, X equal to A plus Z. Okay, so initialization most of the time happen on the top of the program. So any value that you need to initialize, we put it on top of the program. Okay, one symbol for one initialization, so that you will not get confused. Okay, same goes for equation. One symbol apply for one equation. Don't combine more than one equation in one symbol. Okay, so this is what this equation will looks like if it is not repeated. Then if there's a repeated statement, okay, straight away we must put a condition. If you are applying while loop, okay, while loop, okay, so we use this symbol. Okay, this is where we require counter for the decision. Okay, the second elements of the counter is in the decision. Okay, decision. Color. Okay, decision. So what should we put over here? Okay, if you compare with the decision if, okay, if or a case, kan? So we put if, kan? That is different. If it is a looping, it's also a decision, but we put a keyword for looping, which is, in this case, while loop. Okay, the first type that we use over here is while. So put while. Okay. If it is a decision, normal decision, if, kan? So this is a looping, we use while. Okay, and the following is the same. So we put the condition over here. So what is the condition? Condition in looping is where we set the maximum value of the loops. For example, we want our program to be looping 4 times, kan? This one, 1, 2, 3, 4. Okay, it must repeat 4 times so that user can enter each 4 times. Okay, so we must set this to be the maximum value of the counter. So counter start with 0, 0, 1, 2, 3. So it must stop at value 3. Counter equal to 3 is the maximum value for this looping. Okay, if you put counter equal to 4, meaning that 0, 1, 2, 3, 4. That one is 5 times. That one is 5 looping. You understand me, class?
Yes, sir.
Okay, so this one supposed to be the stopping criteria for your looping. Okay, so we want it to stop. This again is rational symbol, same as we use it in a decision. For example, if we put 2 over here, what will happen? Okay, counter start with 0, 0, 1, 2 is true or false?
False.
2 less than 2, which is false. So it repeat only 2 times, 0 and 1. 2 already false. Okay, so this is how you control the looping, the number of the looping. Okay, so clearly if you want to run it for 4 times, if you use less than symbol, so this one should be 0, 1, 2, 0, 1, 2. So if 3 then false, it will exit the looping. Okay, so let's say if you want to use this symbol, what should be the value over here? 0, 1, 2, 3. Is it correct?
Yes, sir.
Are you sure this one is correct? your looping start with 0. Okay, 0. I think I have to write this one. 0. Okay, this is one loop. 1. Okay, 2 loop. 3.
No.
Sorry. 2. 3. How many loop?
4.
0, 1, 2, 3. This one correct. Kan? But if you use less than 0, 1, 2, 3 is not included, kan? So if you put 3 over here and you use less than symbol, then you will only get 3 loop. We require 4 loop. Okay, you understand this class? So this supposed to be what? If you use less than
4.
Less than
supposed
4.
to be 4, kan? Okay, 0. Okay, 0 true, 1 true, 2 true, 3 true, 4 false. Okay, false we didn't include lah, because it's by default.
Less than 5.
Sorry?
Sir, count less than 5.
Count it as 5.
Yes, sir.
No,
No.
because it is less than. So
Yes, sir.
4 is not included.
Yes, sir. Yes, sir.
Okay?
Okay.
4 is not included because it is false. Okay, 4 cannot be less than 4. 4 less than 4 is false. 4 is equal to 4, kan? Unless if you use this symbol, less than or equal to 4, now it become 5. Okay, now it become 5 loop, which is wrong. We require only 3 loops. So if you use less than or equal symbol, this number should be 3. So it will stop at 3. Okay, 0, 1, 2, 3. 4 loops. Okay, so now we got the starting criteria and the stopping criteria correct. Okay, this is how you set your looping, your loop number. This is the starting looping. This is the end of the looping. Okay, so now let's move on. So we have this correct. Let's move on to the next, which is the body of the looping. Okay, the body of the looping start over here. Okay, when the condition is true, okay, when the condition is true, it will enter the body. So this is the body. And it will, this is why it is repeated. So once it go to the body, it will return back to the condition. So this is the body. This is the body. Okay, you can see a circle over here. Over here. So this is the body. Okay, loop body. So any repeated statements, we put it inside of this body over here. Okay, let's put the first statement. So this is the statement that is repeated. Okay, we put it in the body. And of course, you cannot use H1, H2, H3, H4 kan. So no point to use looping kan. So when we use looping, normally over here, we use general name lah. General variable instead of specific 1, 2, 3 kan. So we use only 1, enter H. And then it will repeat. Supposedly, it must repeat 4 times. Okay, let's check. Okay, common mistake. Okay, common mistake done by the student is they forget to put the last elements for the counter. So what happens if you forget? Okay, let's check this. Okay. Okay, this is false. Go somewhere. So this is true, So this is true. This is false. True, This is false. Okay, so start counter 0. Let me remove this, This is just for explanation, You may put anything, If it is not repeated statement, put it over here. Okay, but this one straight away to the repeated statement. So this one straight away to the decision. Okay, counter 0. Okay, counter 0 less than equal 3. True, kan? True, kan? 0 less than equal 3. True. So user enter age. Okay, go. So what's the value of counter? Now. What's the value of counter now?
0.
1.
It's still 0. Do you see anywhere that the counter change? It's still 0. Okay, 0 less than equal 3. True. Enter age. What's the value of the counter now?
0.
Still 0. True. Enter age. What's the value of counter now?
1.
T.
Still 0. Enter age. What's the value of the counter now? Still 0. Enter age. 0. Enter age. 0. Enter. So how many loop already?
Still now 0. Then enter is still now 0.
Yeah, it's still 0. It's still 0. So it is what we call as infinity loop. It doesn't stop. Okay. So your program will run, and then the memory will crash. Okay. It run without stopping. So this is where what we call as infinity loop. Because you forget to put the counter update. So we need to update the counter so that we doesn't stuck with infinity loop. Alright. So when we put the update, we put counter update at the bottom of the loop body. So let's say we consider this at the bottom of the loop body, meaning that the last statement in the loop body. So this is the loop body. It should be the last statement. Okay, over here. So put the assignment symbol. And we update the value of the counter. So how to update the value of the counter? Counter equal to counter plus 1. So this is counter update. Okay, you may apply this in any program that involving looping. The update always the same, most of the time. Okay, so now let's check. Okay, counter 0. Okay, 0 less than equal 3, correct. Okay, enter age. So what's the value of counter now? Over here. What's the value of
1.
counter? Correct. 0 plus 1 kan. So initially the value is 0. So 0 plus 1. Now the value of the counter is 1. Okay, now move. So 1 less than equal to 3. True or false?
True.
True. Enter age.
1
Over
plus
here.
1.
1
Counter 1 plus 1.
1. Okay, correct. So now the value is 2. Goes back up. 2 less than equal to 3. True. Enter age. Now the value is
2 plus 1, 3.
correct. Okay, goes back up again. 3 less than equal to 3. True. Enter age. Okay, now the value is
4.
4.
4. Okay, 4 less than equal to 3. True or false?
False.
False, and then it exit. So you see, it repeats 4 times and it match with our requirement 4 times. So now we complete the elements of looping: initialization, decision, update, all involving the counter. Okay, the same, counter, counter, counter. Okay, doesn't matter what name you use over here. Okay, if let's say you use X, but don't use X. X. So this is X, this is X, this is X. Okay, just replace it with X. Okay, so now let's complete the program. Let's identify what should be inside of the loop body. So this is repeated. Okay, this is supposed to be in the body. So this is supposed to be in the body. You don't have to create new looping just for this. You can create new looping just to calculate this, but it is wasting the resources. Okay, you need to create one more looping just to calculate this. Okay, but you may combine with this loop, no problem. So put it over here and use appropriate accumulation equation. So this is where we apply the accumulation equation. So general equation for accumulating is accumulate. We want to accumulate. Okay, in this case, okay, this is the general equation for accumulation. In this case, we want to accumulate value of x for each of the loop cycle. Okay, if you have 4 loop, you want to calculate x for the 4 loops. Okay, 1, 2, 3, 4. So the variable that we want to do the accumulation, we put it over here. We replace with x. Okay, this one you may replace. So in this case, we want to calculate sum, kan? We want to accumulate sum. Okay, so use sum equal to sum plus what class?
H.
Right. Okay, so the basic is total equal to total plus x. Okay, total is what variable that you want to store the value of the accumulation. X is the value of variable that you want to accumulate. So in this case, x is h. You want to accumulate h, kan? H plus n. So this is equal to this equation. Okay, this is when we put it in the looping. So is it done, class? If we just put it like this. Okay, let's check. Okay, counter 0. Okay, 0 less than equal to 3. Okay, let's say user enter h, and then we have the value of sum. Then we have, of course, the counter. Okay, this is just to note down the value. Okay, so counter 0. Go, user enter h. 2. Okay, so over here, what's the value of sum? Sum equal to
0.
what? What's the value of sum?
2.
2. How do you get 2? Sum plus 2. So what's the value of sum?
0.
Where do you got 0?
Because we don't define sum.
If you don't define the initial value of sum, you cannot get sum equal to 0. The value is null. So sometimes your program is going to give incorrect value for the calculation because you didn't put exactly what's the value of the sum. Okay. In order to calculate sum, you need the value of first sum. Okay, which supposed to be 0. So how to put this value 0 is over here. So in the conclusion, if you want to use accumulation in your program, make sure you initialize the value of the variable. If you use sum for accumulation, put initial value for sum equal to 0. If you use total over here, put total equal to 0, so that your program may calculate the first run of the looping. Otherwise, it will not get the value of sum in the first loop. First loop, kan? This is just the first loop. It couldn't find the value of sum. Okay, now let's test again. So we have counter 0. Sum we have 0. Okay, sum of 0 over here. So counter less than 3. Enter H, user enter 2. Okay, now sum equal to 0 plus 2. So now sum equal to 2, kan? Okay, so counter update. Counter plus 1. Counter become 1. It goes back up again. 1 less than equal to 3. True. Enter H. Okay, for example, user enter user enter 4. Okay. So 4 plus what? Plus 4 plus
2.
2. Correct. Okay. So the value of sum is 2, kan? So 4 plus 2 equal to 6. Then counter plus 1. 1 plus 1. Now it become 2. And so on. Understand, class?
Yes, sir.
Okay, you see the accumulation happen before the update. Update should be the last. Okay, so that you didn't confuse it with other process. Okay, other equation. Okay, now let's compare it. Where should we put this equation? Is it repetition process?
No.
No, we already identified this as not repeated. So it should be execute only once. So where should we put it? Should I put it over here? What if I put it over here? What will happen? Is it going to repeat or not? If I put it over here, it's going to repeat or not?
Repeat.
Yes.
Yes.
Yes, of course, because this is still within the body of the loop. So we repeat 4 times, okay, which is not what we needed. So this is supposed to be where?
False.
Okay, correct. If this is false, then it will do this. Okay, meaning that we already finish this. We finish this. We finish this. We finish this. And then it will do this, and follow the flow. All right. And finally, we print this inside or outside?
Outside.
Outside. If you put it inside, it will print 4 times, which is still not tally with this flow. So we want it to follow the original flow, but only this time we apply looping. So user will not know we apply looping because they cannot see the program, kan? They only run it. So when they run the program, they will see this flow, the same, which is the same. However, the design already been changed to looping. Okay, and finally the end lah. Any question?
Saya tanya.
Yeah.
Cara kita tulis variable tu tak kisah. Ke bebas.
Variable for counter.
Counter.
It's up to you. Okay. Sometimes the question specifically mention a specific variable for the counter. You just to make sure you understand what is a counter is. Okay, and then you may apply it anywhere. Okay, using any names. Okay, any names. Okay.
Okay, faham.
Any other question?
Sir,
Yeah.
what if kalau average tu sum divide by 4 kan? Kita
Yes.
letak sum divide by counter.
Sum divide by counter. Good question. Okay. What if we want to put this sum equal to counter? Okay, what will happen? Okay. Let's say we didn't change anything over here. Okay. So what's the value of the last value of the counter, class? When we run this program, what is the value of the counter last?
3.
4.
3 or 4? 3 or 4.
3.
Okay. Confused tu. You already confused, Okay, let's check. Okay, counter start with 0. True. Update. So it become 1. 1 less than equal to 3. True. Update. Become 2. Go back up. 2 less than equal to 3. True. It's become 3. 3 less than equal to 3. True or false? 3
True.
less than equal to 3. True, kan? True. Still enter the body. So what's the value of counter now?
4.
4. Goes back up again. 4 less than equal to 3. True or false?
False.
False. So what's the value of counter? When it is false, what's the value of the counter?
4.
4 lah. So this is correct. Okay. So you may change this to counter if this is the value. Okay. But what if we start the counter with 1? It should be over here.
4.
1, 2, 3. If you stop with 3, then it will only repeat 3 times. Kan? Betul? 1, 2, 3. 3 times, right? So you cannot stop with 3 over here. Understand, class? So this is supposed to be 4. So that when we apply the looping, it start with 1, 2, 3, 4. Okay? So it will run 4 times. Understand? But if this is a condition, what will be the last value of counter?
5.
The value is going to be 5, kan? Understand this? Dia confusing saya rasa. We start with 1. So we start with 1. Okay, we start with 1. Okay, and then 1 less than equal to 4. Okay, 1 plus 1. So become 2. Goes up. 2 less than equal to 4. 2 plus 1, it become 3. 3 less than equal to 4. True. 3 plus 1, it become 4. Okay, 4 less than equal to 4. True. 4 plus 1 equal to 5. 5 less than equal to 4. Now it's 5. So we are at 5. Okay, 5 exit. So the value of counter is 5. So you cannot use this anymore. Okay, if this is the starting point and ending point, If you want to use counter over here, what you need to modify? Counter minus by 1. So that you will get 4. Okay, because you changed it already. So you will not get 4 value, you get 5 value for the counter. So we will need to divide by 4 and over here because we only have 4 each. So average you need to divide by 4. So 5 minus 1, you get 4, and then you may use counter over here. Understand not? Understand? Can you understand, class?
Faham, sir.
Okay, this is a possibility that you may put in your design. Boleh? If you don't want to get confused, then use 0. Okay, 0 for the counter, and this one less than equal to 3. Then you may use counter over here. Right. So this is update. Any other question? Okay. So this is okay. If you see this, okay, you will realize that for this program, user is forced to enter only 4 value of age. Kan? So they cannot enter less than or more than 4. So you are forcing user to enter exactly 4 each. What if user want to calculate more than 4 each? So they cannot use this program. So this type of looping is called as, okay, there are 2 types of loop stopping criteria. Ini saya fikir nama dia semalam. Loop stopping criteria. Okay, there are 2. Okay, the first one is defined by program. It's defined by you as the programmer. You define how many loop should be in your program. For example, this one is stopping criteria is defined by you as a programmer. So it is defined by the program. It is inside of the program, hard-coded, how many times it should be looping. So user doesn't have any choice, doesn't have any control on the loops. Okay, they just input. Okay, defined by the program. Another type is the stopping criteria is defined by the user. Okay, so this one, user have the total control of the looping. User, not you. You are the programmer, kan? You are the program. program because you design the program, kan? Okay, so it defined by user, meaning that it's up to user. Okay, how many each they want to enter. If let's say they want to enter 100 each, so they have the control of it. So that one is later on. Okay, this one we are going to cover this later. Okay, remind me. Okay, defined by the user. For today, we use this one. Okay, this one first. This one later. Defined by program first. Okay, let's move on to the second types, which is do while. Okay, once you understand this, the rest is quite similar. Okay, the structure only different. The concept is similar. You still need 3 elements of counter over here. So we still need this. Okay, we still need this. Okay, the same, right? But the only difference is copy paste lah. Let me copy paste this. Okay, so this is do while. Okay, compared to while, the only difference is the placement of the decision. The rest is the same. Okay, the only difference is the placement of the decision. Okay, so for while, the decision is on top of the loop body. So this is the loop body. Decision is on top of the loop body for while looping. But for do while, the decision is at the bottom of the loop body. So this is the bottom. Okay, after update, we are going to put our decision over here. Okay, so meaning that this one need to be move up. Okay, let's move this up so that we have space over here. Okay, let's move this up. Okay, so this is the body. Oops. This is the body. Okay, you see looping over here. Okay, this is supposed to be at the bottom. So this is if it is true. This is if it is false. So if it is false, it will the same, it will calculate the average and print sum. The same, if it is false, calculate average and then print sum. If this is true, it will enter the loop body. So this is the looping start. Okay, looping start over here. So this point over here, we put the keyword which is do. So this is to point the starting point of the looping. So this is the starting point of the looping, starting with here. Starting here, check the loop body and looping over here. Okay. You see what I've done with the design? I just move this to the bottom of the loop body. So this will follow. Okay, this doesn't change, doesn't need to be changed. This just follows it. This goes down, this will also goes down. Okay. Okay, the thing is different is only over here. Okay, once you cut and paste it over here, replace this with do statement. Okay, the starting point of the looping. So what's the difference? Okay, what's the difference? Okay, let's go up again. Okay, you want to compare. So let's say, there's a situation where counter is equal to 4. So what will happen? If counter equal to 4, what will happen?
False.
Straight away it will false. Okay, so the system is not going to execute the loop at all. Okay, at all. It doesn't execute the looping at all if the condition is already false. Okay, during the first run, this one already false. So it just exit the looping and do this one. Of course, without proper value lah kan. Sum 0 divide by 4. 0 So it will print 0 and that's it. Okay, it will not enter the loop body at all if the condition is already false during the first run. So what happened if we change this value to 4? Okay, the same. Okay, we use it for value. This one we change, instead of 0, we change it to 4. So what will happen? Is it going to enter the body or not? Is it going to enter or not? Right. It will enter the body because it doesn't have any choice. It cannot go straight away over here. This is a flow. We're talking about flow over here. So we must follow the flow. Although the condition is wrong, it still enter the loop body. So this is the loop body. It still enter the loop body, enter H, do the calculation, update. Now the value of counter is what? When it enter the decision, the value of counter is? What's the value of counter?
5.
5 lah kan. This one already 4 plus 1. So 5. 5 less than equal to 3. Is it true or false?
False.
False, but over here it already have some value and counter value, and it will not print 0 over here. Meaning that if the condition is false during the first run, if you are using do while looping, it will enter the loop body at least once. Okay? If the condition is false, it will enter the body at least once. Okay, compared to while loop, if the condition is false during the first run, it will not enter the loop body at all. So that's the difference. Okay, understand? The rest is the same.
Yes, sir.
So which one to use? It is up to you. You may use while, you may use do while, no problem. Okay. Okay, if you open up your before that, any question, class? Any question?
Sir, fast
Okay.
flow chart, one calculation I cannot understand clearly. Some confusion, sir.
Sorry.
Sir,
Can you
fast flow chart, looping chart. Some confusion, sir.
sorry.
First one.
I couldn't hear you.
Sir, this is not, sir. Sir,
Sorry.
sir,
I'm
fast
really
one,
sorry.
sir.
Huh?
Fast one, sir. Fast one.
Fast?
This, sir. Fast flow, sir. Up, sir. Up.
Go ups?
This, sir.
Or this one?
Yes, sir. Yes, sir. This congregation sum equal to sum plus is, then sum value is 0, but is value what, sir?
This one 0?
This, sir. Sum equal to sum value is 0, but I cannot understand is below.
You cannot understand why this is 0.
This, sir. I understand this is 0 because sum equal to 0, but sum plus is below I cannot understand.
You cannot understand H?
This, sir. Yes, sir.
Okay. H is the value that we got from user. Over here. So user may enter any value. over here kan? You didn't understand why this is 2. Is that what you mean? This is 4. You didn't understand this? Is it?
Okay, sir.
Okay, age can be any value. Okay, because this is user enter over here. So this is just an example. Okay, it can be any value. For example,
Okay, I
10.
understand, sir. Yes, sir.
Okay.
This, sir. Sum equal to 0 and a is below is any a is below. Then counter equal to counter plus 1.
Okay.
Okay, sir.
Okay. All right. Okay. Okay. So this can be any value lah, because we are following this design over here kan. So later on we are going to see much more complicated example. Okay. There can be decision. Okay, inside of loop body. There can be another looping inside of looping. Okay, there are many possibilities. Okay, so this is just a simple example.
Okay, sir. I understand, sir.
All right. Any other question? Before we moving to algorithms. Ada? Any other question? Okay, please download the notes. Okay, from the notes you see in the page. Okay. Page 16. Okay, you will see that this is a general algorithms for while loops. So how do you write the algorithms? Of course, up here we have the rest of the algorithms. So I would like you to convert the flowchart, okay, that already done by me, convert to the while algorithm. Okay, not just a looping part, the whole algorithm. Okay, including the looping. And also over here, this is page 16. And then we have do while over here on page 24. You see? We have do and then slightly indent, okay, slightly to the right. Okay, the instruction within the loop body. And then we conclude the looping with the while. Simple, right? So I give you 5 minutes. Wait, simple only, kan? 5 minutes to convert these two to while and do while algorithms. Okay, complete algorithms. Okay, do it in the Microsoft Word. Later on, I will ask some of you to share your answer. Okay, 5 minutes. Boleh, eh? Okay, finish class. Okay, Siti Noraida. Siti Noraida.
Yes, sir.
Okay, can you share your screen? Can you share your answer?
Saya paste dekat komen je boleh? Chat box.
Format tadi tak? Oh, boleh eh. The algorithm name should be apa ni? While. Oh, while. Okay, sum average. Okay, alright. So this is correct. This one average line number 9 ni should be in line with while lah. This is not belong to while kan. So this should be over here average in line with while and print. Okay. Okay, good. Simple Show Mingkang. Can you paste the do while?
Wait for a while. I'm not finished yet.
Do while.
Yeah,
Not finish.
not
Okay.
finished yet.
Muhammad Azikuddin. Muhammad Azikuddin. Ada Muhammad Azikuddin. Mana Muhammad Azikuddin? Iman. Iman. Iman ada Iman.
Ada sir.
Boleh share?
Sekejap sir, saya share screen boleh?
Boleh. Dia bagus. Sekejap Okay.
Ni sir, yang bawah ni.
Okay. When you put read, it shows that it need input from user. So Don't use read lah. Initialization, just
And
put
enter.
no read, no enter. Just put count equal to 0, sum equal to 0. That's it. That's how you write down initialization.
Okay, sir.
Same right equation. Okay. Itulah indent kan. Count and do should be in line. It should be in the same indent. Okay. Read each. 0, 1, 2, 0, 1, 2, 3. Okay, count less than 4. Boleh. Alright. Belum lah.
Oh, belum lagi sir.
Kejap.
Sorry.
There's one thing I want to highlight over here. Okay, for do while, for while, of course we need to end with and while kan. But for do while already the last statement, so no need to put and while. Remove that. So it's supposed to be the decision should be the end of the statement. Okay.
Okay, sir.
Alright, thank you.
Thank you, sir.
Okay, thank you. Any question? I'm not going to continue with the automatic loop. That one we will cover after the midterm break. So we are going to have a break kan? Next week, betul tak kelas? Midterm break is next week. Is it correct?
Yes, sir.
Yes, sir.
You already been forward kan? Forward pula. Sekejap Let me share the attendance first So we will continue after midterm break with the automatic loop and also the rest of the chapter lah. Loop chapter Yep. Okay, no question If no, then fill in the attendance. Then thank you. Assalamualaikum.
Thank you, sir.
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 Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.